Hey guys, this is Miss Page, and we're going to step away from kind of our normal stuff, and we're going to do an activity that I'm going to put in my journal, my class's journal, and I want y'all to do this along with me, and we're going to prove the formulas for circumference and the area of circles. And in the process of doing that, we're going to review a little bit of vocabulary. So you need 2 of these papers, and the reason why will be clear to you in a little bit. So let's look at the first thing, which is the radius of the circle. Okay, the radius of the circle is the distance from the center of the circle to the any spot on the circumference of the circle. Okay, so it's the center of the circle to any part of the outer outline of the circle. Okay, and the distance here, the radius is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 units long. And we're going to color the radius red, go away black, because radius and red both start with R, and it's just something to help you remember. The radius is red. Radius red is only halfway across the circle. Okay, so the radius is red. And then the distance all the way across the circle, so that was this, from here to here. The distance all the way across the circle is 10 units. Okay, so I'm sorry, not 10, it's 20 units, because the radius was 10, and then all the way across, 2 is double that, and that is called the diameter. And the reason why I'm doing the diameter in black is because it starts with die, and die is death, and death is black. So I don't know why, but that just works for me. I hope it works for you too. So I'm going to color this in diameter. I'm not going to push down real hard, because if I did, you wouldn't be able to read it. So I'm making the diameter black, and remember the diameter is 20 units long. The radius is 10 on the circle, and the diameter is 20. Okay? And then the last word that we're going to review is circumference. Pi is just a constant that is given to you. It is an irrational number, and it is 3.14. Okay? Pi is the constant relationship between the diameter and the circumference of a circle. Okay? It is any circumference of any circle, if you divide it by the diameter, will give you pi. And the other way around, any diameter of any circle, distance all the way across it, if you multiply it times pi, 3.14, and that's not exactly what it is, so that's the reason why you got this little wiggly equal sign that just means approximately 3.14, because it is a decimal that goes on forever. Anyways, what I was saying was, if you multiply the diameter times that, you get the length of the circumference. So if I take this diameter, which is 20 units long, and I multiply it times pi, 3.14, then I'm going to get this distance around the circle, which is 20 times 3.14 gives me a circumference of 62.8. Okay, so I'm going to make the circumference green. I don't have an explanation why I'm going to make it green on this one. I just am. There we go. Circumference, green, green, green. There we go. Okay. So the reason why it's 2 lines here is because this paper wasn't big enough to put 62.8 units all in a row. So this is half and this is half, 31.4 and 31.4, which all together makes a circumference of 62.8. Okay, So 10, the radius, 20, the diameter, multiply that times 3.14, and you get the circumference of 62.8. Okay? All right. So let's show what that looks like by taking these labels and putting them on the circle. Okay? So take your scissors, and this is going to go in your journals, and we're going to label it with each of these different pieces. Okay, I'm going to go ahead and cut it all the way out. Here we go. Goodness. Okay, I'm going to take this, cut out the radius. And got to cut it exactly at the end of that line, where the radius is 10 units long. Okay. And I'm going to stick that right here. It's the distance from the center to any point on the outside of the circle. I can rotate this all the way around. As long as I keep the center on the center. My fingers are butterfingers. You see? The distance all the way around. No, whoops. Not doing a very good job of showing what I'm trying to show you, but it's all the way around. Okay, so I'm going to stick that right there and glue that down. And I'm kind of in a hurry for the sake of the video, so I'm going to just staple that on there and move on. So that's the radius from there to there. Now we're going to cut out the diameter. Again, cut it right at the end of that line. It's exactly 20 units long this time. Got the snifflies. Okay. I'm going to put this going straight through the center, and the diameter is the distance all the way across the circle, passing through the center. Okay, so again, y'all are just going to glue this down, but I'm in a hurry. There we go. So there's my diameter, there's the radius, and then the last thing that we're going to do is we're going to take the circumference of the circle. And we're thinking, how are we going to get this straight line to go around the circle? It works. It does. So I'm going to label the circumference. That's the distance around. I just cut the word circumference off because my arrow is pretty long and that would go off right there. So, and now I am cutting out the circumference. We need pretty thin lines, and right here it's halfway almost, because remember it's 3.14, so if you multiply that you get 31.4, so it should be a little less than half when you cut it here, a little less than half of that square. So now sniffle, sniffle, snort, snort. Cut your circumference exactly at that line, and 31.4 times 31.4 means this is 62.8 units long if we put them end to end. Okay, there we go. There's my circumference of the circle as a straight line. If I took this and I chopped it and I straightened out that line, this is how long it would be. And let's see what that looks like on here. So to get me started, I'll do what I've been doing and just staple it on there. But what we're going to have to do is make little folds in this, little bitty creases, to make it go around the circle. And it's not going to be perfect, guys, but it's just to show you that it actually is going to work. Okay, so stick that on there. Sniffle, sniffle some more. Uh-oh, I may have left a little bit extra on there. Oh well, that's okay. So my stapling messed me up. That's okay. There's that part of the circle. And then we start this one here. We get it right on that line. Let's be as close to perfect as we can be. There we go. And fold it. Now don't be bothering your teachers for their stapler, because you can just glue this down around the edges. Again, I'm doing this quickly so this video doesn't take up our whole class period. We sure don't want that. We got too much to do. Just spend our whole class periods watching videos. Okay. Go, go, go. Go, go, go. All the way around, all the way around, all the way around. Okay. So it ended up a little bit short, but the reason for that is because of my crazy folding. I know that y'all will do a better job than I did. Okay. Oh wait, there it goes. It ends up in the right spot. Okay. So, see? We got the circumference, the radius, the diameter, everything labeled. Ah. Okay. So, the only other thing that we're going to use from this page is this. And this is the proof of the circumference formula, which is circumference is equal to pi times the diameter. It's also equal to pi times 2 times the radius. Okay, so you could add that to your title of the page. You write that on there. Circumference is equal to 2 pi r, which is what the diameter is. 2 times the radius. Okay, so if you're given any one of these, the diameter or the radius or the circumference, you can figure out what any other one of those is by plugging it into those formulas and rearranging it as needed. Okay? So let's move on to proving the area formulas. I'm going to set these to the side. Take my other paper and my trash out of the way. So proving the formulas, the formula now for area. Remember, area is equal to pi times radius squared. And now I'm going to explain to you the reason behind this weird looking stuff over here. Okay? So thought I had a yellow sitting right here. I want to do the area of the circle in yellow because it kind of reminds me of the sun. So, here we go. Here's a yellow. If I count this, you remember the radius was 10? So So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. And then this right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is also 10. Okay? So remember, this says radius squared. So if I square the radius, that means radius times the radius, or 10 times 10. Okay? So that means the area of this is 100. And this square, including this line up here, I made a mistake when I first made this, and that's the reason why I've got one line added to it, is also 100. And this box in this corner, also 100. So that's 300. Okay? And then if you count how many this is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares. So altogether, you have 314 boxes here. Okay? And that's significant because look at this. Pi is 3.14. So there's 314 boxes. If you multiply pi, 3.14, times 10 times 10, you get 314. Okay? So 100, 100, 114. So if we play our cards right, this right here better be the same size as this circle. So let's prove it. And what we're going to do is, one, we're going to cut this out, and we're going to keep this to put in our journal to prove to us the lengths of the size of the original lengths. We're going to cut this off, and just remind yourself that the radius was 10 and the diameter was 20, and I didn't leave myself room. The circumference was 62.8 of this circle that we made. Okay? So keep this as your label for your second page in your journal. And I'm going to cut out my circle. Cut out my circle. Okay, so there's my circle. And here's my 314 square units. There's still a little extra on here, and that's okay because I want to color the whole thing yellow, because we're going to make it look like the sun. Because remember, area is the whole thing, the whole insides of that circle. Should have had one pre-made like they do on those cooking shows, you know, where they make the recipe and then they just finish putting together the recipe and then they pull out the finished product from the stove. Should have had one of these pre-colored, but I guess I wasn't that prepared for this video. Oh well. Okay, I'll do a better job of coloring than I did. Okay, so cut off the extra, make it exactly 314 units. Excuse all of my sniffles. Sniffly queen. There we go. Moving that over. 314 units in a square, oh boy, a circle that should have an area of 314. If we multiply the diameter of 20 times 3.14, no, I'm finding the circumference. See, that's the mistake that students make all the time. The area is what I should have said. 3.14 times the radius, which was 10, squared, which is 100, because remember that's radius times radius. So 100 times 3.14, sorry, gives me 314. 314. Okay, what can we do now? I'm going to do this. I'm going to put this right on top of here, and I'm going to cut this circle out. Look like I'm sitting on top of each other. Y'all will see what I'm doing in a second. You're going to be like, oh, Miss Page. Who knew? Who knew? Okay. So all of the white stuff that we're cutting off, that's going to be trash. But all of the yellow stuff, that's important stuff. Okay. So take this. And if I had these set up right, this would all be colored in perfectly. Keep my yellow pieces. Yellow pieces. Is that a yellow piece? Yes, it is. Okay. So, I'm stapling. Now, if I put this on here, and I put this in here, and I cut it up into little pieces so that it's covering all those little bitty white areas, it should be exactly enough to cover up this circle. Yeah, how exciting is that? So that's what I want y'all to do. I want to finish that up. I don't want this video to last forever again, so just take a minute and be getting this to where there's a single layer of yellow that covers up all of these little white open spaces. So there, I'm going to take that and put that right there. It does not have to be exactly like this, guys. Your job is to fill up the white space. Okay? And you're gluing it on those spaces. So that's poke it out over there, and this is poke it out over here. We cover up all of that white space, white space. You see? And when I do it, oops, this is overlapping that. It's a single layer, and it would all be covered up as one single layer. Those 314 circles adds up to the area of that original circle. Isn't that cool? Okay, so I told you to keep some things as we were going through this. I want to show you how I want it in your journal. Oh, stifle, stifle, breathe, breathe, breathe. Alright, so here's my journal. One side I'm going to have area. So I'm going to prove the formula for area, and that's this one. With this side is what we did. I'm going to stick this in there because this is my original length of all that stuff, and I'm just going to glue that down on one side on here so that I can use it to look at it for both of those. And then I'm going to glue the circumference side down here, and I'm going to color that green. Circumference is green, and I'm going to make those formulas green as well. Okay? Get those glued down in your journal. I hope this helps y'all to understand where these formulas for circumference and area come from. It's very, very common for students to get these two formulas confused and figure out circumference when you're supposed to be figuring out area, or the other way around, figure out area when you're supposed to be figuring out circumference. So, have a good picture of what they mean and what they're talking about in your minds, and this will help you so much. Also, sometimes it's going to ask you for the diameter, sometimes it's going to ask you for the radius, and it's actually going to give you the circumference or the area. You all have the skills to rearrange formulas. You just need to substitute them into the original formulas and solve for whatever is missing. Okay? All right. Y'all have a wonderful day. Thank you for listening.